I hope I'm audible, and it's really great to have this opportunity to speak to all of you. And as you could have guessed from the title, this talk is going to be quite different from the others that you've seen so far in the last couple of days, right? And I just want to spend a little time about why we think this is an important topic and why I think that it's something that we should all know about and consider. We think that AI is going to be part of our lives in many ways going forward, and we want to make sure that nobody gets left behind, and also no parts of our populations are disproportionately harmed by AI, right? And so it's really critical that the AI that we build is inclusive to everyone. And in fact, this is one of the responsible AI principles that Microsoft also stands by. Inclusivity is one of the pillars that we have in our work as well. So what I'm going to do in this talk is I'm going to talk about some of the studies from research that have talked about how inclusive Gen AI is, right? And specifically, I'm going to focus on a few aspects. One of them is language. That is the work that my group focuses on. I'll also talk about culture, ability, and gender. And this is not going to be comprehensive by any means. My purpose is to just give you a taste of the kind of research that has gone on in trying to figure out how inclusive AI systems are, okay? And then at the end, I'm going to talk about our own homegrown AI systems that we are building today in the Indian research community, and our attempts at trying to figure out how inclusive these systems are, okay? So that's what the talk is going to be about, and I'm going to start with the dimension of language, right? So a few years ago, colleagues in my research group wrote this really amazing paper that was very celebrated. It was called "The State and Fate of Linguistic Diversity and Inclusion in the NLP World." And what we mean by this is basically that we want to figure out which languages, language technology, so those would be your machine translation, your chatbots, a lot of the algorithms that are there that are processing your data, how inclusive are they to the different languages in the world, which are more than 6,000 in number. And what they found basically is that 88% of the world's languages at that time, when they did this study, were untouched by the benefits of language technology. And they actually grouped languages into different classes based on how well they were supported by different language technologies at that time, right? So come ChatGPT and the entire generative AI wave, what we decided to do was ask this question again. And it's very challenging to actually answer this question. I'm sure many of you have tried talking to ChatGPT in your own language, but how do you really figure out whether these languages are truly supported by these kinds of AI systems or not? And that is the focus of the research that my research group does in Microsoft Research in India. So one of the things that is really difficult about Gen AI is that it is a complete paradigm change, not only in the way we interact with these systems and their capabilities, but also in the way we build these systems. So the knowledge that we had earlier about which languages these systems worked well in and which ones they didn't work well in, that doesn't really translate into Gen AI kind of systems. So we have to start from scratch, essentially. If we look at some of the data that goes into building these models or training these models, as we call it in the technical terms, we see that actually for models like GPT-3, which is like an old version of ChatGPT, the data that goes in is predominantly English data. And there are tiny slivers of other languages that are also there in these models, but they are very, very small compared to the amount of English data that goes into these models. And as you go into the languages like the Indian languages or African languages, those are extremely small slivers, so you can't even see them in this pie chart, right? And so that means that what is going into these models is very, very skewed, right? So maybe that means that these models are not going to do well on languages other than English. However, the situation is more complex than that. So what my team and I have done is really try to dig in to what are the factors that influence how well this model is going to do on a particular language, right? So many people may have tried to, as I said, talk to ChatGPT in their own language. The fact that it's able to respond doesn't mean that it works in that language. there are many other aspects that are required for it to be able to work in a particular language, such as how well it completes a particular task, whether it is safe or not, whether it is giving you biased and toxic content. It shouldn't be doing that in your language. It should be culturally appropriate. It should also not hallucinate in that language, etc. Only if it satisfies all of these different conditions, only then we can say that this model actually works for a particular language. And figuring all of this out is not easy. I'm not going to go into the details of this, but what we basically did was a multi-pronged approach, including having large-scale human evaluations, so asking people who spoke a particular language to give us very detailed evaluations of how good these systems were. And in fact, the work that we have done at Microsoft Research India is the most holistic and comprehensive evaluation of these Gen AI systems or large language models in non-English languages today. So we are actually the leaders in this field right now, and we've done multi-pronged, multi-dimensional analysis of this. So I'll tell you what we found. So we found that LLMs actually perform worse on non-English languages, so languages other than English. There is a big gap. So the performance that you see for ChatGPT when you talk to it in English, you're not going to get the same performance in other languages, right? We also found that for languages that are written in scripts other than the Latin script, which is what English is written in, the performance is poorer. We also found that languages that are from language families, which are different kinds of categorizations of languages, for example, the African languages or the indigenous languages or the languages of the Americas, etc., those languages tend to perform quite poorly. And we also find that languages from economically poorer regions also perform poorly, right? So what is the sort of, what does this imply? This implies that there will be a certain section of the population who doesn't speak English, who are not going to get these benefits of Gen AI like the people who speak English will, right? And if Gen AI really becomes such an integral part of our lives, of our work, of our personal lives, etc., then there's definitely going to be a disparity for the people who speak one language versus the other, right? And so, I don't want to paint a very bleak picture. We are working very hard to address these kinds of challenges. Now that we know how to measure very well, we are also looking at how to improve systems, and we have some initial promising results. Another thing that may be, relevant to some of the startups and the smaller organizations that are trying to get these systems into their processes, right? There is this class of models called small language models, which are smaller, cheaper, faster versions of giant models like ChatGPT, right? And you may want to integrate them into your applications because they are much cheaper, faster, etc. We found through our extensive evaluation that actually these small models are even worse than the larger models on languages other than English. So this is really bad because it means that, if you're trying to find a more frugal solution, you cannot go with these right now. Right? So this is another direction that we are exploring, how to make these small language models actually work well for other languages. All of this is from our research work, which has been published in the top NLP conferences. And finally, one more thing that we found, this is actually from colleagues at the University of Washington, is that not only are these systems less performant in other languages, they may be more expensive also. So for the same task, for a language like, say, I think it is Burmese over here or Thai, right? You would be spending 4 times the amount of money to do the same task if you're paying for token by token access, right? Which again increases the inequity of this whole thing, right? That's about language. So I'm going to quickly talk about some of the other dimensions also that I want to cover. So culture, right? So what is culture? Culture is very, very difficult to define. People have so many different sort of dimensions that they use in order to, come up with their own cultural identity. So it could be what region you're from, it could be what language you speak, it could be, what gender you are, it could be your socio-economic status, etc., right? And ideally, you want your AI system to be able to understand your culture and adapt to it as well, right? So some of our colleagues have done this analysis where they took something which is called the World Value Survey, where this is a survey which basically tries to see what the different values are that different geographical cultures prioritize, okay? So over here on this graph, you see basically things like traditional values versus secular values, and you also see things like survival versus self-expression, etc. So there are very extensive surveys that are carried out in the world. And what they tried to see was, where does a GPT-like system fall in this, right? What kind of region does the GPT-like system actually map to when it comes to these kinds of surveys, when it comes to these kinds of values, right? And of course, each individual is different, so you can't generalize like that to the entire population, but these are the broad trends that they see in each of these geographical regions, right? And so they find that actually the GPT kind of models lie in very much an English-speaking Protestant kind of cultural identity when it comes to these kinds of values, right? So again, this means that these models are not really doing well, or they are by default more Western-centric than a representative of other cultures. Now, what kinds of implications that will have when these models interact with us every day? Those are again things that need to be studied, but this is something to be kept in mind. We also did some work in our own lab where we took various cultural artifacts from all over India. So things like food that is important to a culture, festivals, dance forms, etc. And we basically asked these large models to recognize these artifacts or to tell us more about these artifacts. And in the graph there you can see dark green are the states where these models were able to do better, and the lighter greens are the ones where it was doing a bad job. Right? So for some states in India, these GPT-like models are actually able to recognize a lot of artifacts, so a lot about your own culture, whereas in other states it's doing a bad job, right? So again, this points to this inequity. Next, let's look at ability. So this is based on some work that my colleagues have done at Microsoft Research in Cambridge in the UK. So they were basically looking at models that process images. So this is not just your ChatGPT-like model where you talk to it via text, but also some model that can look at images and try to make sense of the images. For example, take an image and detect all the objects in that image, right? So that's the kind of task these models do. And what did they find? They found that these models actually underperform on objects, on recognizing objects that have something to do with disability, right? So some of the objects that blind and low vision users use, these models are not able to detect those objects. Also, another interesting finding they had was that if the application is that a blind or low vision person is talking to this AI model, trying to find an object in their surroundings, right? That's the application say. The words that they use to describe that object may not be the appearance of the object, may not be the color of the object, it could be like the texture of the object, right? And when given these kinds of clues to identify the object, these models underperform a lot. And why is this? This is usually the problem, why there is, underperformance on these kinds of aspects is because the data sets that are used to build these models do not have representation from these kinds of objects or this kind of language, right? And so, as I mentioned, the description of objects by material is almost not present in these data sets, whereas it's always by color, for example. So these are some of the things that they found. These are just some pictures of some of the objects that these systems are not able to do a good job of recognizing. Another point they make is that a blind or low vision user who's taking a picture of their surroundings may not be able to take a picture that's perfectly in focus, right? Or that has the entire object in its frame. And again, these kinds of images, these systems do very poorly, right? So these systems actually could be so useful for these communities in order for them to live a very independent life, right? But because of the way that they're trained currently, we know that they underperform for these communities, right? So there is a lot of work again going on trying to improve the situation, now that we know that this is a problem. And then finally, I'm going to talk about gender. So gender has actually been very, very well studied. So bias when it comes to gender, whether it is stereotypes or whether it is performance. So for example, in speech recognition systems, one of the problems that used to happen, so this is when you talk to your phone and it understands what you're saying, is that the female gender, the voice, used to be recognized much more poorly compared to the male gender. And this was again because of the way the data sets were created, where there was much more representation of male voices than female sounding voices, right? That problem to a certain extent has been resolved because this has been known for a long time, but there are still these different performances for different kinds of genders, right? There are also stereotypes. There could also be like a male default gender. When you're talking to such systems, it assumes that you're male. And there has been some work recently, there's been some work recently on trying to do these word association kind of tests with Gen AI. So in the previous, era of the AI systems, it was known that words like doctor are much more correlated with male gender in these models, inside these models, than words like nurse, which are much more close to female, right? And so these cause all sorts of biases when it comes to processing text, generating text, etc. For Gen AI systems too, they've found similar things. So if you ask the model to pick 10 words to describe a male doctor, it picks different words, and if you ask it to pick words that describe a female doctor with no other information, it picks a set of different words, right? So these kinds of discrepancies exist, and the community is trying to come up with different ways to measure this, to quantify it, and then to improve the situation. So this is what we found when it comes to inclusivity. There are many other dimensions that I didn't cover, but it seems like this is something to be really aware of when we are integrating these systems into our daily lives, right, and to our work. Right? And so having systems that can evaluate, first of all, how good or bad the situation is across different dimensions, and then come up with strategies to actually improve is really important. So I'm going to just end for the last couple of minutes and talk about some of the new work that we've been doing very, very recently, which is on trying to do the same kind of analysis on Indian language models, so Indian language Gen AI. And we want to find out how inclusive these models are. And if you've been in touch with this community, there's been a proliferation of different models that have been created by both startups as well as larger organizations, like Ola has come up with this Krutrim effort, for example, right? And so there are a whole bunch of them. There are more than I could fit on this slide. And of course, there are some of these other huge models like GPT-4, like the ChatGPT one, the one by Google called Gemini, etc. So there are so many models now. But how inclusive are all these? How well do they perform for Indian languages, right? We don't know. So currently, actually there is no way to determine how good these models are. And so we started this effort called Pariksha, which is meant to be like a scalable, democratic, and transparent, inclusive evaluation of all of these models. And the problem currently, and I won't go into all of these details, is that currently there is no known way of doing this evaluation with the techniques that we have on board, like the techniques that we've used for our previous work. So we needed something new. So what are we doing here? This is super unique. So some of you may have heard of this organization called Karya. It was recently on the cover of Time magazine. And this is an ethical data company where they're actually trying to bring people out of poverty by giving them dignified AI labeling work to do, right? And so we thought that we want to test systems, we want to see whether they are good at Indian languages or not. We want to do it for all cultures, all languages within India, right? We want that reach. And we really want to, try and tap into different kinds of demographics as well to tell us whether these models are good or not. So why not use the workers that Karya has access to and really make it, this kind of population has never really contributed to evaluation, right? And this is the first time that we're tapping into this population to tell us whether the AI is good or not, right? And that's what the Pariksha system is. So I won't go into, what we are doing, but the general principles here are that it is truly inclusive. By having all of these people tell us whether these models are good or not, and of course based on all of our evaluation research, we can get a picture of whether we are making progress in the right direction with all of these Indian language models or not, right? And so I just want to flash this. This is our very first leaderboard that we have now. This is the first time that we are sharing this. So this is the results of the first evaluation that the Karya workers have done on all of the models that we tried out in this pilot round. And what we are seeing is really nice actually. So there are the giant models like GPT-4 that are still doing best on Indian languages. And by best, we are testing for various dimensions. So I won't go into that. But some of the homegrown models are not very far behind. And so you can see results actually on the left for Hindi and on the right for Kannada. So some of the homegrown startups are actually doing quite well. They're still not beating the giant models, but they're certainly beating some of the other smaller models like Mistral and Llama from Facebook, from Meta, for example. So this means that we are going in the right direction. We're still not there yet, where we can claim that these homegrown Indian language models are truly doing very well on Indian languages, culture, ethos, etc. But I think we are getting there. And our Pariksha evaluation promises to do this in a very fair, transparent, and inclusive way to really figure out whether we are going in the right direction or not with Indian language AI. So with that, I'll stop, and I don't know if I have any time for questions, but happy to take some.